CPU cycles are not our limitation at this point. Instead, it's shifted to what do we do with these massive amounts of data? And it's become such a data-rich endeavor that it's really developing and learning about tools that can allow us to pull information out, to get at the science. When we started, we were dealing with MySQL, very small databases, trying to look for patterns in these data. And we quickly realized that just didn't scale. We were too big for that, and it was too cumbersome and slow. And so this is where Microsoft really came in. We made this hybrid, relational, multidimensional database, and it's working quite well, and we're getting answers to questions that we're asking, and we've got a product that's helping us get there. We're doing things that have never been done before. Without the input of Microsoft, this project would not be taking off. We would not be where we are today, and we wouldn't have this rich database, this information about proteins that are helping us to design drugs against amyloid diseases.
Turning very large amounts of data from the health service, from special studies, from deep observations into meaningful signals absolutely requires computing. Before the Microsoft partnership in shared genomics, there was a very long lead time into getting genomic experiments. Doing look-see science would take 3 or 4 years to become part of a genomic consortium. Shared genomics is allowing us to bring those people together to think through whether the signal they're seeing is a real and meaningful signal. Working with Microsoft has allowed me to introduce some easy-to-use tools that I can deploy both in the university environment and in a health service environment.
What we really need then is tools to enable that the scientists themselves can very naturally ingest their data into the system and begin to browse it and organize it in ways that they think about the data, rather than having to translate it all to a computer scientist, have them deal with the data. Funding through Microsoft, we've been able to actually look at how the commercial products can adapt to the science arena.
We want to take something like Excel, SharePoint, SQL Server, and just sort of apply them to the science, get up to speed as quickly as possible, and really help the scientists deliver scientific insight.
What we actually need is much more focus on the data preservation from the onset. So the computing has very much focused on raw horsepower, so to speak. And that's still important, as I mentioned, but we also need to be a little bit more strategic or a little bit more focused in terms of the interaction between data and computing, rather than computing independent of data. We just started looking across all sorts of sectors, and it was really our astronomers who said, you ought to talk to Microsoft. They're helping us translate or bridge, in some sense, those two worlds.
Historically, engineers have tended to use Linux machines for their largest calculations and Microsoft just on the desktop for their workstations. So what we're looking for are tools that are more appealing and more usable by people who are not trained computer scientists. With the advent of the new compute cluster software, then the option is there to do the whole thing in a Microsoft world. We offered for a while our students the choice. They all use the Microsoft platform for choice because it's so much easier for them. A byproduct is it's easier for us to manage those facilities, so that helps too. And we suffer no performance loss. The calculations and the machines run just as fast. So for us, it's a no-brainer. We will probably never buy another Linux big compute cluster in our group because there's just no need of it.